Hi everyone, my name is Edward Jin. Welcome to Lab 3 Circuits for Physics 2212. So for a little bit of introduction and purpose, the main goal of this lab was to explore how electric circuits behave, focusing on the principles of charge and energy conservation. Using a virtual circuit simulator, we observed the behavior of resistors, calculated current and voltage, and examined how these values interact within a circuit. Here, our system was defined as the circuit itself, and everything else was considered the surroundings. We used a few fundamental principles that principles and concepts that we will be using throughout this lab. The node rule, where it essentially says that the total current entering the junction equals the total current leaving it. The loop rule, which states that the total voltage around any closed loop is zero. And then Ohm's law, relating voltage, current, and resistance. Now jumping into the actual experiment, in part one, we used two ammeters to place at different points in the circuit with total voltage of 3 volts, two 1.5 volts batteries, and resistors of 47 ohms and 100 ohms. And we calculated the predicted current to be about 441 amps using Ohm's law. In part two, we reversed one of the connections on one of the ammeters. And interestingly enough, nothing changed. The current reading remained at 0.2 amps, just like before. This helped reinforce the idea that reversing the meter didn't change the constant current flow. It only affects the direction the reading would show. And here is part three, where we involved adding a voltmeter. Since the voltmeter had extremely high resistance, it drew almost no current, and it showed a steady reading of -3 volts, and the ammeter registered zero current. This makes sense because the voltmeter doesn't allow the current to pass easily, and the circuit didn't have anything else drawing current. And here is the voltage drop, where we use the loop rule, and this allowed us to find out the result in the current remained to be about 0.02 amps. And then in part four, we replaced the voltmeter with an ammeter in parallel with a 100 ohm resistor. This caused the total resistance to drop significantly to just 47 ohms, because current takes the path of least resistance, though through the ammeter, which ideally has near zero resistance. And then we also calculated the voltage drops each component using a voltmeter and Ohm's law. By placing the voltmeter probes at various points, we could determine the potential differences and verify our circuit behavior. And then now we move on to RC circuits, and we timed how long it took to change and discharge a capacitor with different resistances. With 10 ohm resistors, it took about 9 seconds to charge. With 20 ohms, it took about 18 to 19 seconds. The discharge times were very similar, showing predictable exponential behavior. And using a 9 volt battery and 30 ohm light bulb, we predicted the RC time constant to be about 6 seconds, but our calculated value actually came out to about 4.608 seconds, determined by finding the inverse of the slope from our changing curve. And here is some of the information I just mentioned with all of the numbers. And then also I want to talk about the sources of errors that we needed to consider. This is a purely virtual simulation, so it does not always perfectly reflect real-world behaviors. Obviously, some things will be left out in terms of other various factors. Timing the capacitors discharge manually may introduce some slight inaccuracies due to human reaction time when stopping the watch as well, and this could lead to inaccuracies in data. And finally, some discussion questions. So what if you were doing this experiment in real life and use an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter, and how would it have affected the circuits you hooked it up to? So if we use a real ammeter instead of an ideal one, the current would probably decrease slightly due to the meter's internal resistance. And for the second question, similarly, using a real battery and capacitor would show a more gradual charging curve compared to the ideal case where the capacitors would appear to charge instantly. And this about wraps it up. Thank you for listening.